welcome to Research in Focus. I'm Gretchen Huizinga. Today we're going to talk about data analytics in the cloud, and I'm talking with distinguished scientist Surajit Chowdhury and researcher Bailu Ding, both in the DMX group of Microsoft Research, data management and exploration. Thanks for coming today, both of you. So let's start with a level set. Give us an overview of the field of data analytics, and then in general, what are the new research opportunities in data analytics?
Okay. Data analytics has been a very active field of work, both in the industry as well as in research. A simple way to say what data analytics does for you is we collect data, and data analytics is sort of the technology that allows you to get to the insights in the data. And that insights in turn leads to a lot of business innovations. So when you step back and say, what have we achieved so far? Today, we can deal with huge volume of data, tera and petabytes of data, and in many cases, exabytes of data. So we can process a lot of data well, and we can handle scale. But this scale, although we can handle it, is not cheap. Handling at large scale costs us money. So that's one challenge, how to reduce the cost of data analytics as we go along. The second problem is, while we can process data well, getting the data into the data analytics systems is a lot of work. And that process hasn't yet smoothed as much as we would like that process to be. Because the smoother you make that process, the more is the reach of the data analytics, because it can get in more data and handle those. The second aspect of that is configuring this machinery of data analytics is not simple. And if you don't set it right, it would often not perform as well as you want. And this is sort of the second challenge. And the third challenge that I think we feel is very important and goes back to the point about cost is how can we sort of get back of the envelope answers? Because this really makes it easy for us to deal with large volume of data at relatively low cost.
So what specifically are you doing to get to that in the research community right now?
So one area is approximate query processing. And what that does is it says, when you ask me a question, just as we do in real life, if you stop me and say, how much do you think how long it will take you to cook this dish? Or, how long it will take you to go from point A to point B? I might give you an approximate answer. I say, well, I think I'll be there between 20 and 30 minutes with all the traffic and everything included. And yes, of course, today we have maps and everything that makes it easier. If I ask you how much it will take you to cook this dish, I'll say, yeah, 25 minutes, half an hour, what it is. This we haven't used as much to this large collection of the data. If we did, then, and we can answer these questions relatively snappily, in effect, I'm using a lot less resources to answer those questions.
Right.
But it is important that these answers are not way off, because I'm using these answers to decide where we sort of focus to investigate.
Right. Well, I'll ask you about that in just a second. Researchers are always trying to shorten the amount of time between when data is born and when we get insights from it. So what's the felt need there in our current data analytics landscape? What problems are we trying to solve with that shortening of the time?
I think that the shortening that time is important, because if you look at the pace of the world today, like I'll give you an example. A supermarket decides to have a sale event, right? Or a departmental store is going to have a sales event. So they want to launch the sales event, but they want to get feedback based on how the first few hours went to understand what they need to change, either about pricing or the modality. So they want to react quickly to the incoming data.
Right.
Of course, in a robust way. So if they can't get that data in sufficiently early, the sales event or the promotion event would be over before they can do a course correction or intervene. And I think that's sort of an example case where getting the data in quickly and being able to analyze in a timely manner is important. And that goes back to your point of shortening the gap in time between analysis and ingestion of data.
Right. So Bailu, talk
Yes.
to us a little bit about the idea of auto-tuning in cloud databases. How do cloud databases differ from regular databases? And ultimately, how do we get rid of manual tuning, or do we need to do that?
Okay, so the databases have been evolved into a very powerful but also complicated piece of software.
Yeah.
So it provides a lot of tools or naps for the user to customize the database so it works best for their own applications. The issue is precisely the user needs to figure out what are the best configurations for their application and to get the most out of the database. So previously, there has been work on how to tune the indices for databases. But this, again, provides another toolkit for the user. It requires the input from the user. And the user needs to use their judgment to decide when to use this tool and how to use this tool. Right. So this is just like nowadays, it's easier to drive a car with automatic transmission than manual transmission. But you still need to pay attention to your surroundings to decide when to accelerate and when to slow down. Right. So the vision of this project is to automate the end-to-end process of database tuning so that when the user just need to specify the metric and the target they want to have, and we will figure out how to get there, and we actually go ahead and really get there for you. Right. So in terms of the cloud, actually Azure provides a unique opportunity for us to know within a database and know across multiple databases. So by tracking legal telemetry from the cloud, we can transfer and generate this learning to millions of databases in Azure.
That's awesome. Let's go back to approximate answers for a second, Surajit. Why would in a database query, because I understand the idea of you asking me a question, I'm going, well, I guess 20 minutes. But if I'm going on my computer and I do a query, I'm thinking I'm going to get something exact, and that's what's been aimed for, hasn't it? Why would close enough be better than for sure?
Yeah. So you have to think about cost. If you don't think about cost or latency or how much time it takes for me to answer the question, approximation would not seem interesting, right?
Right.
And so the challenge here is the following. And as you know, we have been accumulating data at a very rapid pace. So we have lots of data. For a computer to go and look at that data, one of the two things have to happen. It has to be a super powerful computer, means often a large cluster of machines who are all working super hard to get that data out, and that costs money. Right. If you think about how much work the computer is doing, the time, money you are spending, in the world of cloud, this would translate into money. It would be a lot of money to answer your question exactly. Mm-hmm. Alternatively, it will also take a lot of time to answer it. And unless you bring all these resources to bear, very much large clusters, what that means is that trying to get the answer, have to wait for quite a while. Right. So either from the latency or from the cost, or sometimes from both, getting an exact answers in a world of big data, when a lot of data has been accumulated, is expensive. And what we are trying to do is to give you a mode of answer where you get a back of the envelope feel for the estimate before you go and spend that money to get the exact answer. So we are not at all saying exact answer is not important or that world will go away. Absolutely. But we are trying to have a portfolio that not always I have to seek exact answer and spend a lot of money. Instead, what I would do is work in a world where I sometimes ask for an estimate, and based on the estimate, I may say, now let me ask the exact question, because I really want to know this in an accurate way.
Right. So is there going to be some kind of customer retraining in expectations or expectation management in an approximate world versus a for sure world?
The reality is approximation happens already today. Yeah. If you think about what happens today when I face a large data collection and ask, I'm going to analyze that data, often out of the need to get an answer quickly or to spend less money, we say, just take last 3 months data. Don't bother looking at older data. Just look at the last 3 months data, right? Or just look at last week's data. Or just look at the data from Pacific Northwest. For now, don't look at the other region. So the customer base is already tuned to the notion of approximation. That said, these approximations are kind of ad hoc approximations, where out of necessity, they're making some ad hoc calls to see which part of the data they look at. What we are trying to do is to say, let's bring to bear the foundations of sampling, sketches, and other powerful tools that we have innovated, we in the broader scientific community and statistical community have innovated over sometimes decades or in recent years, and bring it to bear to answer approximately in a principled way. Yeah. That's the journey we are in. Yes, there is some adjustment to be made, but I think the idea of approximation is not new.
Yeah, people kind of have that
Exactly,
expectation anyway,
exactly.
so okay. So database systems are made up of a lot of moving parts and pieces. How can machine learning and AI techniques make individual components smarter and maybe our systems more robust? Bailu, what would you think about that?
Yeah, I can start. So what I'm thinking about is that, especially for the cloud services, now we have the opportunity to collect a lot of performance metrics, which is not like confidential data, which is not illegal data. It's just telemetry of the execution characteristics of the databases. Once you see one database, you see two, you see millions of them, you are starting to discover some patterns from them. So if you are a new customer come to the cloud, we can leverage this knowledge and transfer our learning to your databases so that you can enjoy this intelligent database feature from the start.
Right. So would you add to that?
So just to rephrase another way what Bailu has just told you is traditionally we have built one piece of software which sort of goes and gets installed in many places. This database system goes on your data, it works, and it works on my data in a very similar way. It has a fixed set of capabilities. It doesn't go and very much tune itself based on your characteristics. It essentially gives an answer in a certain fixed way, no matter which data you point it to. The availability of the data that Bailu talked about, this availability of the telemetry data from the cloud, opens the door for an investigation which says, oh, I'm on Gretchen's world, and in that world, I'm looking that the data has a certain characteristics. And now I know how I can optimize the functioning of this database system to suit her environment better. And if I were in Bailu's work environment, I may see a very different patterns. Maybe she is very bursty on how she asks questions. And I may do very different strategy on how I optimize the resource of the system. I think where we stand today, that opportunity is very much there, and it behooves us to explore that opportunity. Are we ready today to call it a victory that this data has modified the way the systems are going to be built in the near term? I don't think we are there yet. And the question you raised about robustness is real. Database systems take pride in being a very dependable piece of software in the enterprise. So before we make these transitions in a database based on the telemetry data, we have to be super sure that we have the guardrails to make sure they act in a robust way. So that suddenly based on the data, they don't do something erratic. And this part will require, just like software engineering, needs to be understood much better on how we deal with these ML-powered systems, or specifically ML-powered database system.
Yeah, so the machine learning bit is personalizing the search thing, but it needs more research to sort of solidify whether this is going to be something that's going to play well in my world or Bailu's world.
Yes, exactly, without creating unexpected surprises.
Great.
Yeah, and also just in a few words, there are two aspects of machine learning. One is how do you generalize this knowledge to others? The other one is how do you adapt this knowledge to you? So actually we are doing both dimensions.
Wow, that's exciting. So let's talk about self-service data wrangling. I throw back to the gas stations when self-service was a thing. But first of all, what is self-service data wrangling, and how do machine learning and program synthesis inform the research that you're doing in this area?
Yeah, so when you sort of opened our discussion, you asked what are the problems in data analytics, and one of the problems I mentioned is the journey from having the data to getting it to a point where I'm ready to run powerful analytics on it is a long one. And one reason is, of course, getting the data from a different system where data is being born to the system in which I'm going to analyze it, is sometimes not so easy to get to moving the data from one point to another. The second reason is when the data is born to when I'm analyzing it, often the shape of the data needs to be changed. Like the data gets generated in a certain way, but I want to sort of reshape the data before I analyze it. This task of reshaping, and you can think in terms of, if you are familiar or work with spreadsheets, often we sort of move around and try to shape it in the right way before we sort of run some aggregate statistics or other stuff. This process is what is known as data wrangling, data preparation, data cleaning, and these phases often is extremely labor intensive or human intensive. The push of self-service, data wrangling is to say, how can I make it easier? Not compromise on how you want to shape the data, but instead of a heavy-duty manual intervention where I have to be a rocket scientist to learn it, which automatically means fewer people are going to be able to do that, which means lesser amount of the data are going to be analyzed. Can I put the power in the hand of a user like you, Gretchen? And the idea is, give some examples. If the data is in a certain shape, show me the examples of what shape you want to be for a couple of your data items. And if you show that to me, what self-service data wrangling tries to do is to say, I got your example. I know the kind of programs I can run. I know the space of programs I can possibly do to reshape the data. Based on your examples, I can narrow what program needs to be written. So instead of you writing the program, you simply show the examples. And the program synthesis technology, with the ability of machine learning to rank various candidate programs among using your examples which will fit best your example, can present you with the program on how the data would be automatically reshaped. And this is a very powerful tool.
Yeah. So is this like Autofill or Flashfill, but only with programs?
Yeah, exactly right. That's the right way to think about it. What Flashfill does is that, just for the, just to remind all of us, is essentially you give some example in an Excel saying that, hey, I want this column to be like this. And you're really giving the example of this reshaping for a couple of rows maybe. And then Flashfill automatically helps you fill in the rest, right? And so it has behind it a space of programs it can think about, and it generates from it. Where we are taking this idea, using exactly the same paradigm, which is example-driven for you to indicate the reshaping you want, but we hypothesize many people have written many powerful transforms, and they're available because in enterprises, out of necessity, people have written. What we want to do is to create a search engine for such transformations. The idea would be to give these examples, and these examples allow me to search over all the transforms that we have seen, including the kind of transforms Flashfill is today already capable of, and pick the program that I know of that already meets your requirements. And this allows that, Gretchen, when you write a transformation, Bailu can automatically discover and leverage that. And this, I think, is very powerful. We will expand.
Powerful. Yeah, and I just think of how much Autofill and Flashfill have done for me, speed and productivity-wise, so I don't have to think through all of the filling in each cell and so on, that I can imagine this would be really amazing for this program synthesis world.
And I think this is really, for an area of this data wrangling, which has been kind of a slow-moving field and very manual, this combination of program synthesis and machine learning together have really an opportunity, a kind of a unique opportunity to reshape the field in terms of new innovations that will come. And we are not alone in this, and I think there is a broader opportunity for the research community to do even more here.
Yeah, that's great. And that kind of leads into my last question for you. I'll start with you, Bailu.
Sure.
What would be the goal or vision of this research if in a perfect world you were wildly successful? What would the data analytics and the query and the database world look like?
I see. For me, this is along my research interest in my current project. It's like right now, the cloud services are valuable in the sense that it offloads some of the overhead of management of data and databases off the shoulder of the users, so that the average user does not need to necessarily be an expert in the field, can go ahead and deploy their own database services and use the services without any friction. So my view of the future of this line of work is to make the cloud services even more smart, so that the users don't need to worry about the underlying infrastructure and do a side job as a DBA.
Right.
Instead, they can just focus on their application and business logic and rely on us to figure out how to support them for their applications.
So you need less expertise on the user end, and you can outsource
Basically,
that.
it's more or less like democratizing the database services to average users.
Yeah, or lower than average, as the case may be. What would you say would be the perfect world?
Kind of where we started, right? I mean, I think that from the time the data is born to where we are getting the insights from the data, I want this process to have very little friction and be inexpensive. And if you think about it, today it requires a lot of manual intervention, and as data grows, the cost goes up. And I want to shorten that. I want data is born, I can get to the insights relatively quickly, and it doesn't cost that much. And everything we talked about today lead to that direction. And that's sort of my Uber dream.
The Uber dream. I love that. Surajit, Bailu, thank you so much for joining us today. I'm glad you came in. I look forward to seeing where this is going to go in the future.
Thank you so
Thank
much
you
for the
so much.
conversation.
Great.
Yeah.
And thanks for joining us for this session. We'll see you next time.